4.4, trig functions at any angle. All right, so remember our Native American princess Sokotoa? Remember her? All right, she happened to be a Ayo, all right? So it's just like our unit circle. Sine goes with y, cosine deals with x, tangents y over x, and all that good stuff. However, we also need to talk about its radius. Our radius is the branch that goes out. All right, that's our hypotenuse, and that's how we can think about it. So this first one, I have -3, 4, and I need to find on its terminal side of theta the sine, cosine, and tangent of that theta. So trigonometry means what again? Study the measure of triangles. So guess what we're going to draw a lot of? Triangles. So I have -3, 4. And so -3 does what? Moves which way? Left. It moves left. So it goes left, -3, and then it goes up 4. And it's always going to be connected with my x-axis. All right, so there's my theta right there. All right, and what do we need to solve for? My hypotenuse. So what's my hypotenuse? 5. 3 squared is 9. 4 squared is, we add them together, we square root it, we get 5. All right. So now that I have my triangle, it's pretty simple. So what's the sine of that triangle now? 4/5. All right. And then the cosine of that triangle. Cosine would be -√3 over, or -3/5. And then the tangent is opposite over adjacent, so I'd end up with 4/-3. However, that's kind of bad etiquette, so I would put my negative up top, so we'd end up with -4/3. All right. When x is positive, it moves to the right. When y is positive, it moves up. When x is negative, it moves left. When y is negative, it moves down. All right. I know it's a simple concept, but that's what we're going to be. So we all know our unit circle, hopefully by now. Y is positive, or sine is positive in the quadrants 1 and 2. Sine is negative in quadrants 3 and 4, right? Cosine's positive, cosine's negative. Now, I don't like this this little acronym. Sine, cosine, and tangent are positive in quadrant 1. All right, so all of them, right? And then sine is positive in quadrant 2, so it's just the sine. And then tangent's positive in quadrant 3, and cosine is positive in quadrant 4. The little acronym that some math teachers use is they say, all students take calculus. However, I know that not to be true. All right, only about 10% of students take calculus. All right, so I don't like to use the acronym all, especially when... So now we have this one. I have tangent of theta. I have tangent of theta is equal to -5/4. What two quadrants will give me tangent being negative? The second and the fourth. All right? And so I need to have some kind of constraint on it. And so I have to have a constraint to tell me where to draw it. It's either going to be drawn in the second or it's going to be drawn in the fourth quadrant. So on this one, I have cosine is positive. So what two quadrants tell me cosine is positive? 1 and 4. 1 and 4. So guess where I'm drawing it? I'm drawing it in 4. I'm not using this one anymore. So this is where I'm going to draw my triangle. You see how we did that? All right. So let's do it now. So cosine is opposite over adjacent, right? So my opposite is 5. My adjacent is 4. Now, which one gets the negative? The 5 gets the negative. Why does the 5 get the negative? Because it's going down. All right, that's why it gets the negative. All right. Because, for instance, if I just said cosine of theta was less than 0, guess where I would have drawn this thing? In the second quadrant. And tangent would be 5/4, but guess what gets the negative now? The 4. Why does the 4 get the negative now? Because it moves left. Are you following what I'm talking about? All right. Make sure we're paying attention to that. All right. So now I need to evaluate, and it tells me to evaluate sine of theta. So sine is what? Oh, whoopsies. I haven't found what? The hypotenuse. I need to find the hypotenuse. So 4 squared is 5 squared? We add them together? 41. So what's my hypotenuse? Square root 41. Now I'm ready to find the sine. So sine is opposite over hypotenuse. So I'm left with negative 5 over square root 41. However, what's wrong with it? It's not rationalized. So what do we get? Look at this next one. I got secant of theta. So what's secant? Ha! All right, so what do we get? All right, fantastic. Pretty good? All right. Oh. Sine, that's boring. All right, what's sine of theta?
Was that over hypotenuse?
Just pick two numbers.
Oh, 4 and 5.
4 and 5, you want them negative? You want them positive? What do you want?
I guess. Negative.
You want negative? All right, so we got negative 4 over 5. Fantastic. All right. All right, and Cooper. Let's do cotangent. Why not? Cotangent of theta. Is it positive or less than 0? Is it greater or less than 0?
Greater than 0.
Greater than 0. Fantastic. I love it. All right. So, when can sine be negative? What two quadrants can sine be negative in? Third and fourth. Third and fourth. When can cotangent be positive? In the what? In the first and the third. In the first and the third. So, I am drawing this in the third quadrant.
It's the inverse of, also the inverse of the slope of the hypotenuse.
Sine is what? My opposite of 4, my hypotenuse of 5. But what's my 4? It's negative. Why is it negative? It moved down. All right. Now I need to solve for my other side. So 5 squared is? 4 squared is? We subtract them. What do we get? We get 9. We square root it. We get 3. So this side is 3. It's not 3, is it? It's what? It's negative 3. Why is it negative? Because it moved left. All right. You see how important it is if we know our left, our down, our ups, our rights. Do we understand that? Okay. I need a reader. Thank you so much, Jomar.
Let theta be an angle in standard position. Its reference angle is the acute angle theta.
Ooh.
Formed by the
Whoa. I had you for geometry. Theta what?
prime,
Theta prime. Thank you.
formed by the terminal side of theta and the horizontal axis.
All right, fantastic. The horizontal axis is the x-axis. All right. So all of our reference angles are going to be formed with the x-axis. So there's theta prime, there's theta prime, there's theta prime, there's theta prime. It's all going to be formed with our x-axis. Is it ever going to be formed with the y-axis? Never. Okay. Sometimes I have students that do the y-axis on a test or a quiz, and I'm like, what have you been looking at? All right. It will never. So if it's in quadrant 2, you're going to have to subtract that theta. You're going to have to subtract whatever theta that is from 180, or pi if you're in that mode. If you're in quadrant 3, you're going to have to subtract 180 from that angle. All right? And then if you're in quadrant 4, you're going to have to subtract it from 360 to find your reference angle. I think you'll understand when we do a couple. So let's look at a couple. So 300 degrees. What quadrant is 300 degrees in? It's in the fourth quadrant, right? I did this little jig, right? And I need to find theta prime. I need to find theta prime right there. So how do I get to theta prime here?
Subtract 360.
Not subtract 360, but subtract from 360. So I take 360 and I subtract 300, and then I'm left with my reference angle of 60 degrees. All right, pretty simple. All right, let's do another one. I have 2.3. Is this in radian or degree mode? This is in radian mode. How's it radian mode? How do we know it's in radian mode? There's no degree sign. So where's 2.3 at? What quadrant? It's in the second quadrant. All right, it's in the second quadrant because this one is pi over 2, or like 1.57, right? And then this is pi, so it's like 3.14, right? And so I need to solve for this theta prime. So what do I need to do to it? Subtract, not pi, but from pi. All right, I need to subtract from pi. So now I have pi minus 2.3. So bust out your handy dandy calculator. And we end up with 0.8416 radians. All right. All right, so then negative 135 degrees. What quadrant is that in? Third quadrant. It's in the third quadrant. It's right here. All right. So it's right there. And I need to find this theta prime. So what do I need to do? I need to add 180 to it, exactly. So now I'm going to say 180, which is really subtracting 135, and I end up with 45 degrees. So my reference angle is 45 degrees. So all the reference angles are going to be between 0 and pi over 2 if you're in radian mode, and between 0 and 90 degrees if you're in degree mode. All right, pretty good. They're always formed with what axes? The x-axis. All right. So we all know our unit circles, so let's put it into practice again. So cosine of 4 pi over 3. Well, where is 4 pi over 3? Third quadrant, right? It's right there. All right, so cosine deals with x. So what's my x? Negative 1/2 because it moved left. All right, let's do this next one. I have negative 210 degrees. Mr. Flick, you didn't train me in degree mode. How do we convert from degrees to radians? We multiply by pi over 180. So let's convert. So now I have negative 210 degrees over, or pi over 180 degrees. All right, so my degrees are going to cancel. So what does that simplify to? They're both divisible by what? Negative 7 pi over 6. Good. However, I don't think of negative 7 pi over 6 in my noggin. What do I think of? 5 pi over 6. All right. So really, I want to find tangent of 5 pi over 6. Those are coterminal angles. All right. So tangent deals with what? Y over x. Well, what's the y value of a 5 pi over 6? 1/2. What's the x value? Negative square root 3 over 2. So we have to rationalize it, and we get negative square root 3 over 3. All right, let's do this next one. I have cosecant of 11 pi over 4. Is 11 pi over 4 on my unit circle? No, so what we got to do to it? We subtract 2 pi. That subtracting 2 pi is said to be its what? Its coterminal angle, or its p. Here. Happens monthly. It's a cycle. It's a period. Very good. All right, so we need to subtract 2 pi, or in this case, 8 pi over 4. So I end up with what? 3 pi over 4. All right, I had to use one of its periods. So cosecant goes with whom? Sine. So sine is? It is. All right, so sine is square root 2 over 2. All right, and so we flip it, we rationalize it, and we get square root 2. All right. I need a reader. Thanks, Julian.
Let theta be an angle in quadrant 2 such that sine of theta equals 1/3.
All right, fantastic. So this one tells me where to draw it. All right. So we're going to draw this thing in quadrant 2. All right. So we're going to draw it in quadrant 2. Well, what is sine? Opposite over hypotenuse. So my opposite is 1. My hypotenuse is 3. I need to solve for my other side. So I use Pythag. What's my other side? Square root 8. Good. It's negative. Why is it negative? Because it goes left. All right. So it's negative. Make sure you get that. So now we're going to evaluate for cosine. So cosine of theta is what? So what's my adjacent? Negative square root 8 over 3. And then tangent of theta. So tangent of theta is opposite over adjacent. So what's my opposite? 1, my adjacent of negative square root 8. What's wrong with it? Negative on the bottom and it's not rationalized, so we end up with negative square root 8 over 8. Calculators, all right. I want you to be able to toggle back and forth. There's your homework. There's no copy.